So we have the graph for this question as replicated there on the board, and the question reads as follows. Which of the following relations is represented by the graph shown above? Alright, and I have 4 answers, right? A, B, C, D. And looking at the 4 answers, all this question is asking to find, it is asking you to calculate the equation of a particular straight line, right? We all know what a straight line looks like. That is in fact a straight line. So when they talk about the relation represented by the line above, they are talking about a relation between x and y, right? Remember, the equation of a straight line is basically a relation, a fixed relationship between the x and the y coordinates for any point on that line, meaning that every single point on that line, any point that you can identify on that line, would hold to the relationship which is represented by the equation of the line. So we have 2 points here, so I'm going to work it as if it was a paper 2, right? Because you could get this in a paper 2, and in fact there have been many paper 2 past paper questions where you get a diagram of some sort with a straight line, and they ask you to find the equation of the line, they ask you to find the gradient of the line, etc., etc., etc. So we have a straight line here, and we have 2 points through which the line passes. Now, as I tell my students all the time, right? If you have a diagram of a straight line like this, where you have the where you have the y-intercept, and you also have the x-intercept, if you have to find the gradient of that line, you don't necessarily need to go into the formula y2 minus y1 over x2 minus x1, right? You could just look at the points. So in this case, if remember your gradient is vertical displacement over horizontal displacement, right? Or vertical distance over horizontal distance, however you choose, whatever vocabulary you choose to use to express the concept. If you have a diagram before you, you can see it and you could just look at it and figure out the gradient. So I'm going to do it using the 2 methods. I'm going to do it using the visual method, where you see 2 here over 4 here, right? Remember, we're looking at the measurements that they give us, right? So I can know immediately that the gradient m of this line is 2 over 4, which is equal to a half, right? Simply because I have a vertical distance of 2 matched to a horizontal distance of 4, right? That's the gradient. That is the gradient. And the orientation of the line is in this direction, so we know that the gradient is positive, as opposed to if it was in this direction, the gradient would have been negative. So without going into too much write-up of the formula, we could get the gradient as a half. Of course, the other method, which some students might want to use, is to first identify the 2 points, the y-intercept and the x-intercept. So the x-intercept is the y-intercept is the point 0 minus 2, and the x-intercept is the point 4, 0. So we have identified 2 points through which the line passes, and then we could use the classical formula to find the gradient. So we can say the gradient is equal to y2 minus y1 over x2 minus x1, which will be y2 minus y1, 0 minus minus 2, all over x2 minus x1, 4 minus 0, which is equal to 2 over 4, which is equal to the same half. Now, it doesn't matter which point you use as x1, y1 and which point you use as x2, y2. Alright? So let me switch it, let me flip the switch, as they say in language that is now current, right? We're recording this in early April 2020, and there's this thing where they flip the switch, right? I guess that is something you can always Google and find out what it is about. So let me flip the switch now. So instead of using this as x2, y2, as we did here, we could use this one as x2, y2, and this one as x1, y1. So if we do that, we have y2 minus y1. So m would be, we write over the formula again, just for practice, right? y2 minus y1 minus 2 minus 0 over x2 minus x1, 0 minus 4. 0 minus 4, you get minus 2 over minus 4, which is the same half. So whether you do it using the visual method or you do it using the classical method, you will get the gradient of a half. And of course, using the classical method, it doesn't matter which pair of points you use as x1, y1 or x2, y2. Now that we have the gradient, we have the y-intercept. So if you have a straight line and you have the gradient and you have the y-intercept, then the easiest thing to do is to express the equation in the form y is equal to mx plus c. In other words, you don't want to go using the formula y minus y1 is equal to m and x minus x1 if you have the gradient and you have the y-intercept. You don't need to do that. You only need to do that if you have a line segment in space, right? If you have a line segment somewhere here and you don't really know what the y-intercept is, and they tell you find the gradient of the line or find the equation of the line, well then yes, you use the long formula. But if you have the gradient and you have the y-intercept, either given to you explicitly or they give you it in a diagram, then it makes your life a lot easier. You could revert now to the simplest form of the equation of a straight line, which is the form y is equal to mx plus c. So we're going to rub off this now. And we know the m is equal to a half, and your y-intercept, right, is equal to 0 minus 2. Therefore, the equation of the line is that y is equal to mx, a half, x minus 2, right? That is the equation of the line. Now, of course, none of the answers in this question is of this form. So all it means is that we have to manipulate the form of the equation so that we get it in this form, right? This is the form that you will normally see more commonly used in ADMATS exam. So in the ADMATS course, they will use the form ax plus by plus c is equal to 0. That is another form of the equation of a straight line, right? So that is what they're asking you to do here. So if you got as far as this, right, and in a paper 2 context, this will be more than sufficient 9 times out of 10, all right? But because we're in a multiple choice here where they actually give you the options, you reach here and you realize, well, we don't have that in the answers. So what is the next step? The next step is to manipulate this algebraically to get one of those 4 answers there. So I'm gonna rub this off now and start from the top, right? Y is equal to a half x minus 2. So y is equal to a half x minus 2. Right, so what we want to do now is express everything with a common denominator. Once you do that, it makes life a little simpler. So y is equal to x over 2 minus 2. Now, should I do this or should I not do this? Okay, let me simplify it a little bit. The first step, the first thing I would do is to simplify your right side. So in other words, this here goes directly back to your question 2 in the paper 2, your algebra, right? There's a specific thing in the algebra where you're required to combine 2 fractions into one with a common denominator. And if you go through your past papers, you will see that there are quite a few questions like that. So what I would do here is, all right, let me do. There are about 3 or 4 different ways to do this, right? And I don't necessarily want to do all of them here, but I'll just choose one at random. So x over 2 minus 2 over 1, right? And you do your regular LCM story. So this is the same thing as you come down in the corner here now, and you say x over 2 minus 2 over 1. The LCM is 2. 2 into 2, 1. 1 by x is x. 1 into 2 is 2. 2 by 2 is 4. Minus sign remains, and you have 4. So that's x minus 4 over 2. So your y is equal to x minus 4 over 2. And now you could express this as y over 1 is equal to x minus 4 over 2, which means that you could then cross multiply and you'll get 2y is equal to 1. I'll write it here just for explanation's sake. 1 into x minus 4. And I'll come and rub this off here now. And therefore, you'll get 2y being equal to x minus 4. And then we start to look to see which form it resembles this. Okay, so basically they brought everything on one side, right? So it will be 2y minus x plus 4 is equal to 0. And which answer is that? That is answer D. So the answer for this question is answer D. 2y minus x plus 4 is equal to 0.